Hi everybody, it's Professor Stevens. I'm going to be walking through some student questions that have been emailed to me from the 7.2 assignment. This was actually question number 13, and the question ID, which corresponds with the textbook, is 7.2.17T, and I'll go ahead and read the problem and then we'll walk through how to solve it. In a study of speed dating, male subjects were asked to rate the attractiveness of their female dates, and a sample of the results is listed below, 1 being not attractive to 10 being extremely attractive. Construct a confidence interval using a 95% confidence level. What do the results tell about the mean attractiveness ratings of the population of all adult females? And then the data is given here, and we can open that up in Excel, or you can copy it to a clipboard like this, use Control-C, or just right-click and select copy. If you have your Excel sheet already open, you can open a new sheet if you'd like. I already have one open I can use, so I'll go ahead and paste that in. And so here's my data, and I'm going to need to find the best point estimate from this data. The best point estimate is the sample mean, so I'll go ahead and get my sample mean. I've got my caps lock on. There we go. All right, so to get that, I can use the average function. And I'll also go ahead and get the sample standard deviation, lowercase s is the symbol we use for sample standard deviation. Whoops, I got to type in, if I just type in ST, some options come up, and I want this one, standard deviation dot s for sample. Okay, I'll need this to help me construct my confidence interval. All right, so the formula that I'm going to need to use here, that's not the problem I was looking at a moment ago. Let me pull it open. Hold on one second. All right, here's the question that we were just working with, and in order to construct a confidence interval of the population mean, I'm looking for mu being estimated in between the best point estimate minus a margin of error and plus a margin of error. So that will give me my interval. I already have the point estimate, which I just calculated from my data, so I'll put those values here. So x bar we calculated to be about, let's go back and look, 6.58. I don't know why. Oh, my thumb was hitting the eraser button. And my standard deviation is 2.39 approximately. Now, you really shouldn't be rounding before using values to calculate other values, but just for simplicity, I'm going to do that here. In fact, for the standard deviation, since I'm going to be using it in the error formula, I'm just going to put a couple more decimal places. A lot of times 4 is a pretty safe number if you're going to round. When you're writing things down, go out at least 4 is a pretty good rule of thumb to help minimize round-off error. Okay, now the formula that we need for E, so our margin of error, which is the amount of wiggle room we're going to allow on each side of the point estimate, is using either z alpha half times the standard deviation from the population divided by the square root of n, or it would be t alpha half times the standard error of the sample. And since we don't have the population standard deviation given anywhere and all we have to work with is S, we're going to go with the second option here and use a t-score to calculate E. So we're going to go ahead and use this one. All right, so we'll go ahead and figure that out now. E equals T alpha half times 2.3916 over the square root. I'm sorry, that was probably really loud. I had to sneeze and I couldn't find the pause button fast enough. Excuse me. The sample size, let's see, how many did we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so now all we need to do is find the critical value from the t distribution. So there's a couple ways that we can do that. We can either use Excel or the t-table. So I'm going to show you the t-table first. Okay, so now I have the t-table open. Well, I have the packet open, which is where you will find the t-table. It's not the only place you can find it, but this packet has been provided. You should have a copy of it in your student notebook, and this packet is also provided for you to use during tests. So I'm just scrolling through the pages here, and then this page is the one that we use for Unit 3 and Unit 4 the most often for the rest of the term. And on the back side of that page is a small version of the student t distribution table. So we'll use that first to find the critical value. Remember, we had 12 pieces of data, and the degrees of freedom that we use for the methods in this section are n-1. In fact, all of the methods that we use in this entire course, we will be limiting ourselves to methods that use degrees of freedom equal to n-1. So that will stay the same for all of the methods that involve using a t-score for something. The degrees of freedom will always be n-1. Now we can look down to where it says degrees of freedom 12. It's actually going to be 12 minus 1 since we had 12 pieces of data, so n-1. So our critical value is going to be one of these, our t-score. And it's going to correspond to the correct confidence level across the top, and also with the area in a single tail and the area in two tails. So let's talk about that. For this problem, it says to use a 95% confidence level. So we're going to use a 95% confidence level, and what that means is that our significance level alpha with a confidence level of 95%, our significance level is 0.05. And since our confidence intervals for all the things we do in this course are two-tailed, we will have a critical value on each side, but the one on the right is the one that we're going to be using for constructing our confidence interval. Okay, and so for here it's t-scores. Sometimes it can be z-scores, and we would still have a bell shape, but it would be with a mean of 0. Like this also has a mean of 0 for t-scores, but for t-scores the standard deviation is greater than 1 and varies with the sample size, whereas if it were z-scores, the standard deviation would be equal to 1. So in each tail, half of our significance level, which would be 0.025 in each tail. Okay, so we're going to look in the column in the t-table that has a 95% confidence level, and which says that each individual tail should have an area of 0.025, and the total area in both tails should be 0.05. So let's look at the table again. So here you see where it says 95%, area in one tail is 0.025, and the degrees of freedom, sorry, I didn't mean to say degrees of freedom, I meant to say the area in two tails is 0.05, so that's the total area. And again, we were in the row with 12 degrees of freedom, 12 sample size, and 11 degrees of freedom. Having a hard time spitting that out. So we're in this row, this column, right? So you can see that my critical value from the t-table is 2.201. All right, so let's go ahead and write that down. and then we can calculate E by using that formula. We can also find a t-score using t dot inverse for two tails. I'm putting in a probability of 0.05, which is their significance level, with the degrees of freedom 11. And you can see that it does come out to be a little bit different when you're using Excel. Excel is more accurate. There's a little bit of round-off rule or round-off error in the table. But either one of these will give us an answer that the computer system would accept. So if I'm using inverse t, then let's see. So this is from the table here, or from t dot inverse we got 2.200, I think it rounded off to. Oh no, it does round off to the same, so that works out fine. There's not going to be any difference at all. Sometimes you'll see a difference from the one in the table and the one from Excel, but here it rounds off the same. Okay, so let's go ahead and calculate E now. We'll use Excel to help us with that. So we have the critical value times the standard error, which is the sample standard deviation divided by the square root of n, which was 12. So that's my margin of error, 1.52. Okay, so E came out to be 1.52, is that what I said? Yes, okay. And then to get our confidence interval estimate of the population mean, let me just see if I can put that in here. So we're estimating mu. We're estimating mu, and I'm going to do that one more time. Mu. We're estimating mu, the population mean, to be in between the lower limit and the upper limit that we've calculated. The lower limit would be E, the sample mean x bar minus E. So I'm going to take the sample mean minus E, and the upper limit would be the sample mean plus E. And then we will round off one place more than the original data, because that's the round off rule for measures of center and measures of variation. So I'm going to go ahead and do that. So final answers will be 5.1 and 8.1 as the boundaries for my confidence interval. So let me go ahead and try to enter that. 5.1 and 8.1 was it? Let me just double check that. Yes, okay. And that's that. And then there was another problem similar to that one. Here again, asked for a 95% confidence interval of the population mean mu. And again, we're given sample data, so we will be calculating the sample mean, calculating the sample standard deviation, and then using a t-score, calculating the margin of error. So this one would be worked, and this was actually also emailed to me by 2 students, and this was question number 15, but this one would be worked pretty much almost exactly the same way, just with different values. So I'm not going to do that one in this video, but I will leave it here, and please let me know if you have any feedback about this video or questions, and thanks for watching. I'll see you in class.